Hey there. Today we're going to be trying to answer the following question. Find the area of the indicated shape drawn here. Okay, so shape's a little weird. It's got some unusual characteristics to it. Couple things to note. So this is kind of like the handle of an umbrella, I guess you could say. This is a hollowed out piece, so there's nothing there. And then another interesting part is on this peak here, it doesn't tell us what the measurements of these are, but it does tell us that this is a right angle, that these two sides are equal. So using that information and the rest of the numbers here, we want to find out what the area of the shape is. Don't care about the units, so we don't have to worry about centimeters or where. Just find the area of the shape. So when you tackle problems like these, you pretty much always have to subdivide it into mini problems. So here we could, if there was a formula for the whole area of the shape, first of all, we wouldn't be able to memorize it, so it'd be a little weird. But we do know the area of a circle. We know the area of a rectangle. We know the formula for the area of a triangle. So we can combine all those mini formulas in order to solve for this one big area. So let's kind of color code everything. So I'm going to color code everything up to here in red. So we'll call this umbrella the red one. We'll do this rectangle in blue here. So that will go up to here. We'll do this one here in green. And we'll solve for the little triangle in yellow. So we're going to solve each of those little parts, and then we're going to come back and add them all up. So in order to find the area of the red part, the little umbrella handle section, we need to take a look. Do we know the area of that? A formula for the area of that? Not really. But we do know the formula for the area of a circle. And this shape, we could say, if I can draw it here, well, we can represent this shape as a whole circle. So I have a whole circle. And then we can subtract out a middle part. And then, well, that would give us the area for a donut-like shape. But we don't want that. We want half a donut. So if we found the area of those two shapes, subtract them, and divide it by 2, that would give us the overall area of that little shape. So here, in order to do that, so the area of the big circle is going to be pi r squared, and we'll call it RB for the big circle. Subtract pi rs squared for the small circle, and then we can divide it by 2. So the radius of the big circle is from this point here up to the other edge here. So the radius from there to there is 3. So 2 plus 1 is 3. So the radius of that will be pi 3 squared. Subtract the radius of the small circle, which is just 1, so we have pi 1 squared, divided by 2, where we're going to get 9 pi, subtract pi over 2. That will give us 8 pi over 2, which will be 4 pi. So we've now figured out the area of the red section. So we're gonna, I'll just circle that in black. Okay, so now we need to move on to the blue section. Well, the area of the blue section, so I'll just write out the shapes here. So area of the blue is gonna equal to, well, the base times the height, right? And well, the base of this blue rectangle is 5. 5. And the height, well, kind of got to think of it. So it tells us that this spot here is 2, and we're going to assume that this is the same measurement here. So the height for this shape is going to be 2 as well. So we have 5 times 2, which will give us 10. Okay, and then similarly for the green rectangle, well, that's going to be base times height as well. Now here, so the base of this triangle is this little section here. So this little section here. But we don't know that section directly. However, we do know that this whole length is 5 and this little section is 3. So this spot is going to be 5 minus 3. So the base is going to be 5 minus 3, which is going to be equal to 2. And then the height, well, we know the height from here to here is 6, but we just want the height from here to here. So it's going to be the length of this whole side, which is 6. Subtract this little part, which is 2. So the height from there is going to be 6 minus 2. So putting that together, that will give us 2 times 4, which is 8. Okay, so now we have the area of the green part, the red part, and the blue part. Now we just need to find the area of the yellow part. Now this part's a little bit trickier because we don't know the whole area of the triangle, but we do know the area of the triangle is going to be 1/2 times the base times the height. And on the little diagram here, well, we could call this section the base and this section the height, right? Now we don't know what that is, so we need to solve for A because the base and the height are equal. However, we do know that this side over here is equal to this part here, which, as we found out earlier, right here, is equal to 2. So we know that these sides are equal, and we do know that the measure of this side. So we can actually use the Pythagorean theorem in order to solve for this. And we know that the theorem is c squared equals a squared plus b squared. Well, here, our a is equal to our b. So we're going to call that a squared plus a squared. So c squared is really equal to 2 times a squared. And we do know c, which is the hypotenuse, is equal to 2, so we are really trying to solve for a. So we can rearrange this, divide both sides by 2, and take the square root, and that will equal to a. And c, we know, is equal to 2, so we can put 2 squared in there. Just to save a little bit of room, I'm going to round this side. So that'll be the square root of 2 squared, which is going to be 2 times 2, over 2, which is going to be equal to the square root of 2. So you know a is equal to the square root of 2. So both sides are equal to the square root of 2. So the base and the height are equal to the square root of 2. So the area of this little triangle is 1/2 times the square root of 2 times the square root of 2. And root 2 times root 2 is equal to 2. So we're left with 1/2 times 2, which is equal to 1. And that's the last remaining piece of area. So, putting these four parts together, we know that the area of the shape is going to equal to the total area, which is going to equal to 4 pi plus 10 plus 8 plus 1. And this total area is going to give us 4 pi plus 19. And that is how you find the area of weird shapes. First, you need to take a look at the shape, see what measurements you are given, and then figure out what measurements you need, and then find the area of subshapes, and that will give you the area of your total shape.